So here I would like to teach you about some basic formula of differentiation. So there are 5 formulas here. I would like to introduce it to you. First, the number 1 here will be the differentiation of indices. So we actually have it in the index form. So very easy to differentiate the indices, right? You can bring down the power and minus 1 on the power. Okay, formula number 2, differentiation of x is equal to 1. This one you can just memorize it. Rule number 3, differentiation of any constant. Differentiation of any constant. Differentiation of any constant is equal to 0, any constant. Differentiation of, this one is actually a function, but there's a coefficient in front. So we can just bring out this constant and then differentiate it. So it's quite independent. So this is quite simple to know lah. And then the formula number 5, for any addition or subtraction of 2 functions, you can then differentiate them independently and then join them. So the below 2 example, I'm going to use them to demonstrate above 5 formula to you. So just very simple, but just pay attention to it. Okay, for example number 1, let's say you have this to differentiate this 5 term. So to differentiate this 5 term, what we have to do, if you take note of it, we have 2 surds here. So we have to convert them into the index form first. So then we can apply the formula number 1. So after you convert them into the index form, next step you need to do is to bring out all the coefficients. Let's say the 2, you have to bring it out. -5, you bring it out. 3, you bring it out. -2. And this is a constant. You can leave it here. So then now we can apply the above 5 formula to do a differentiation. So you see, you leave the 2 here, and then you bring down the power 4 here, and the minus 1 on the power. So it becomes 4x cubed. Differentiation of x, remember, we have the formula number 2 here. So you can just replace the differentiation of x is equal to 1. So it will be -5 times 1. Next is this one. We can bring down the 1/3 and minus 1 on the power. So and then -half, you can bring down the -half here and minus 1 on the power. Differentiation of a constant, remember we have seen from previous formula, differentiation of any constant is equal to 0. So then we can obtain, Then simplify it, we get this. And the last step, we convert the index form into the surd form, and this is then done. Okay, second example. So let's say you have actually quadratic expression. What you need to do is, the first step to do is to expand it. Why is it so? Because only then we can apply the formula number 1, which is the indices. We have to convert to the index form before we can actually do the differentiation. So expansion, then bring out the coefficient, and this is a differentiation of the constant. So then apply the formula number 1, leave the number 4 here, bring down the 2 and minus 1 at the power, we left with 2x to the power of 1. And then this one, differentiation of x is equal to 1. So differentiation of 9 is a constant, will be 0. So that's why this is how you get the final answer.